For countless millennia, Mars has been the silent, crimson promise in the night sky, a parallel world, close enough to dream of, yet distant enough to defy us. We conquered the moon, but that was just practice. The true test of our ambition is not a visit, but a second beginning. The colonization of Mars is humanity's ultimate imperative, a survival mechanism against global catastrophe, and the defining engineering challenge of our species. Mars today is a landscape of stark, beautiful desolation. It is defined by three fundamental hostilities: bone-chilling cold, averaging -60 degrees centigrade, an ultra-thin atmosphere composed mostly of toxic carbon dioxide, offering nearly zero pressure, and a complete lack of a global magnetosphere, leaving the surface exposed to lethal cosmic and solar radiation. Simply stepping onto the Martian surface is a journey into an extreme void. To survive, the first pioneers will live beneath the soil, using the Martian dirt, or regolith, as a shield against radiation. The initial habitats will be pressurized, interconnected vaults, a pressurized island of Earth on a hostile shore. This pre-positioned infrastructure, deposited by uncrewed cargo missions, will include the crucial in situ resource utilization (ISRU) machines, designed to live off the land. The key to survival is independence. Resupply from Earth is slow, costly, and unreliable. The colony must become self-sustaining. The primary resource is water ice, locked beneath the surface, particularly near the poles. ISRU technology will drill and melt this ice, using it for life support, and splitting it through electrolysis into breathable oxygen and hydrogen fuel. The thin atmosphere, while toxic, is a resource. Its abundant carbon dioxide can be processed, either chemically or through biological means, to produce more oxygen and carbon monoxide, which is a potential feedstock. Within pressurized domes, the first Martian greenhouses, pioneers will cultivate crops in controlled hydroponic or aeroponic systems, supplemented by the regolith once toxic perchlorates have been leached out. The first breath of Martian-made oxygen, the first bite of Martian-grown food, these will be the true milestones of colonization. The human body is an Earth machine, and the journey to Mars imposes extreme physiological stress. The 6 to 9 month transit through deep space exposes the crew to intense galactic cosmic rays, risking long-term damage like cancer and neurological impairment. Protection requires heavy shielding, perhaps using water or cargo to line the spacecraft walls. Once on Mars, the low gravity, only 38% of Earth's, poses another long-term threat. It is unknown what effect this prolonged low-gravity environment will have on muscle strength, bone density, and the cardiovascular system of the colonists, particularly any children born there. To mitigate this, colonists will face strict daily exercise regimes and may rely on artificial gravity simulating devices within their habitats. Surviving Mars is as much a medical challenge as an engineering one. But the ultimate vision is not merely survival in bunkers, it is the radical transformation of the planet itself, terraforming. This is the great work, a monumental undertaking spanning centuries, aimed at turning the red planet green. The initial, most crucial step is to restore a thick atmosphere and warm the planet. One concept involves deploying enormous orbital mirrors to reflect sunlight onto the polar ice caps, releasing frozen CO2 into the atmosphere. Carbon dioxide, a powerful greenhouse gas, would then trigger a runaway effect, thickening the air and raising the global temperature. Another radical proposal involves creating an artificial magnetosphere at Mars's L1 Lagrange point to shield the planet from the solar wind, preventing the newly thickened atmosphere from being stripped away into space. As the climate stabilizes, the next phase is biological. The Martian soil lacks organic material, and the air lacks sufficient oxygen for humans to breathe without assistance. This is where extremophile organisms will be introduced, genetically modified microbes, algae, and cyanobacteria, which can survive the harsh early conditions. These biological pioneers would perform the slow, patient work of a new genesis. They would break down the toxic perchlorates, enrich the regolith, and, through photosynthesis, slowly begin the trillion-ton task of sequestering carbon and producing free oxygen. The end result, centuries later, would be an atmosphere where water can run freely, where trees can root, and where humans can walk the surface without a pressure suit. Colonizing Mars is a statement about our future. It is a long-term, multi-generational project that forces us to think on a planetary scale. It will demand unprecedented innovation, global cooperation, and an unflinching commitment to the long view. From the first shielded habitat to the final, sweeping plains of a transformed world, the Martian journey represents humanity's truest ascent, the moment we cease to be a planetary species and finally claim our destiny as citizens of the solar system. The challenges are immense, but the reward is nothing less than the dawn of a new civilization. For our next episode of Cosmic Vanguard, we will zoom out from Mars to explore the ultimate energy question, fusion power. We'll delve into the science and the world-changing potential of finally achieving safe, contained stellar energy right here on Earth.